Hello, my name is Anton Kolonin, and today we are going to talk about reputation systems and liquid democracy and how these can be used in human societies, in computer systems, and in environments, including both humans and computers. And we'll talk about that from perspective of SingularityNET project and Aigents project. First of all, let's consider the notion of democracy and what specific makes a liquid democracy as a democracy. On the left, we see how the anarchy works. So anarchy is most democratic form of democracy, so everyone can manage everyone can make orders to everyone, and so everyone is equal. But in real life, we know that it never works, so any anarchy eventually leads to some kind of structural organization in society, and the simplest form of structured society is despotism, with one alpha male managing the rest of the pack or rest of society. So that's not quite fair. So humans have evolved more democratic form of social organization with the democratic voting and elections for leaders, and the simplest form of selecting the leader, like president or else, is direct democracy, when everyone has a right to vote and everyone votes and selects the single person. However, that's not easy in large communities with scales of current countries and nations, because it needs too much effort to nominate every person needed in the government, or to nominate every manager in the city, or in the parliament, or in a congress. So we in most of modern societies we use representative democracy, when people are selecting some representatives like delegates or voters or trusted persons, and these delegates or voters or trusted persons are performing further voting in respect to particular rules or particular laws, or election of other people executing management of a society. That's not working quite well either, because, for example, if we decide to select some delegate or some president at some time, and then we realize that that's the delegate or congressman or even president is not good enough because of some reasons we can figure out during the term, then it gets quite a lot of effort to change this person, because the election procedure is very complicated, is very costly, and so in most cases we need to wait when the term ends, and we need to keep with delegates that we selected at the previous iteration. And given the advances in computer technology, given computer powers that we have, and given technologies that can prevent faking the voting process, like blockchain or other technologies of distributed ledger, we can implement what is called liquid democracy. So in liquid democracy, there is no fixed levels of representatives. So if some person has enough reputation, has enough power, voting power, then this person can potentially affect decisions being made on the very top level. On the other hand, if you have some people who are not knowledgeable enough to select to vote for delegates or congressmen, but then they have some trust in their neighbors or close relatives or good friends, they can delegate their votes to the friends or relatives, and these friends or relatives can perform the further voting. So actually the number of levels in the representative hierarchy may be different, it may be dynamic, it may be changing over time, and the actual voting process can take place anytime. So we can provide the supporting or rather non-supporting vote for any person, for any law, for any item, for anything at any time, given the computing power and computing systems that we have, and the processing can be done immediately, and we can see the level of reputation, the level of trust for every president, executive person in some municipality, or any delegate or congressman at any time, any day. Actually, current computing systems provide infrastructure which can potentially let implement such liquid democracy at scale of the human globe. Practically, we have two kinds of segments of the internet with different possibilities of implementing such reputation systems. The one segment is non-China internet, mostly covered with Facebook and Google, and almost every person who owns personal computer or a smartphone, they have accounts either with Google or Facebook, or likely both of them. And as opposed to China, in China, Facebook and Google have very limited availability, so Google is almost unavailable and Facebook is not available at all. But in China, most of population is covered with WeChat, Baidu and QQ systems, which actually within the China borders can implement the same principles of computing reputation of everyone and everything at real time. Moreover, in China there is experiment ongoing. There is huge planet-scale social experiment called implementation of so-called social credit system, and this social credit system, supported by government, provides that anyone can make a rank or provide estimation of any action of anyone, and then in real time every citizen of the country may have their reputation, they call it social credit score, computed, and given on that social score particular rights can be granted or not granted to a person. Like if you have a social credit score below some threshold, then you may not be allowed to enter a plane or a train because you are potentially dangerous person for society and for transport in the transportation environment. Now, with implementation of Internet of Things, and further with making these devices on the Internet of Things more intelligent, we are getting much more interesting picture, because when we consider 7 and 5 billion humans and approximately 3.5 billion connected to the worldwide internet on monthly basis, in current year we have more 15 billion of Internet of Things devices, and more devices will be coming in the next year. So it is expected that in the next few years there will be 100 more devices than humans on the planet. And it is also expected that more and more devices will be capable to perform intelligent actions, because they will be supplied with functions of artificial intelligence. And also we know that reputation systems are quite reasonable to use in these environments of self-driving vehicles, self-driving planes, self-navigating drones, because in that cooperative behavior they can perform better than other than without of them. Like if you consider navigation of driverless vehicles on the road, then you can consider that driverless vehicles communicating one with another in respect to road conditions, road emergencies, they can all perform like a huge collective brain, transferring information on the road and then perform more safely cooperatively. On the other hand, this cooperative behavior of self-driving vehicles has some dangers. The danger number one is that someone can hack into it. So one can, for example, provide some fake news to the community of self-driving vehicles on the road and let all self-driving vehicles to move towards particular toll road. Like imagine that there are traffic jams fakely reported, and then all cars are trying to avoid these jams, being headed to the toll road, and that fake news attack may be actually sponsored by the owner of this toll road. That's one example. And you can imagine more malicious example when some traffic jam may be actually provoked by some kind of terroristic attack incurred by some hackers or some intruders with some bad ideas in mind. And the problem we have here is that we still have problems with our election system, so it's quite difficult and expensive to validate the results of elections. But now imagine that this communication in self-driving vehicles is happening with speed of internet traffic. So no human will be able to detect reputation faking and reputation gaming and these fake news problems happening in community of self-driving vehicles on the road at the time when cars are driving and the signals are transferred with the speed of electromagnetic transmission. So the problem of computing reputation right and being this reputation somehow under control from humans is quite important for the Internet of Things. And what is interesting is that in these computing systems, we see the same patterns and possible structural organizations of communities of devices or robots or artificial intelligence entities building these systems. That the same that we have in human societies. Like the simplest and most democratic organization on the left is a completely distributed system called peer-to-peer. That's something that is being promoted as a basis for blockchain system organizations, but it barely works because if you have a lot of communications and if you have a lot of participants in the system, then performance of the distributed system is quite poor. So then you need to somehow complicate the system, making it more centralized. In ideal case, you have it centralized, like have every control operation being confirmed or conducted by some central control, like have every transaction to be transferred via the same banking system, or it can be decentralized, like in the middle at the bottom. Like we can have main node at the top, we have some decentralized nodes in the middle, and then we have end nodes conducting transactions through these middle layer nodes, and then only in case of conflict the top layer node is resolving conflicts across middle layer nodes. And the beauty of liquid decentralization scheme powered with liquid democracy mechanisms is that it can be liquid. So based on the transaction flow, based on the system capacity, based on the actual communication patterns with the system can reorganize itself. So in some cases, each and peer can communicate directly to some central control node at the top. In the other cases, some decentralized centers of control in the middle can perform control of some smaller communities of system members. And in some cases, even further, the control may be delegated to lower level nodes, so they can communicate the transactions, operations, and control at the more fine-grained level. So we have the same problems in distributed and decentralized and any multi-agent computing systems as we have in human societies. And the key problem that we have in both cases is how to reach consensus. The consensus is a way to actually come to some common decision in respect to interests of multiple users or multiple participants, be these participants humans or robots or self-driving vehicles or whatever. The simplest form of reaching consensus known from the ancient time is force of power. So those who have greater muscles, longer teeth, and more brute force, they can manage the packs, then can manage the surrounding peoples, and they manage the others just by brute force or brute power. Similarly, this approach is somehow used in the blockchains such as Bitcoin and Ethereum. In the blockchains it's called proof of work, and it means that the more power you have, the more chances to govern network state you have, and so you can either buy more power or you can just perform acquisition of individual miners, connecting them into the pool, so you can manage the pool as one point of accumulating the power, and then you can have a way to actually manage the network behavior. The more advanced kind of consensus which was invented in human society with invention of money, and this is most popular proof of way of achieving consensus in human societies by now, is proof of power. So the more money you have, the more power you can buy. So you can buy everything. You can buy media sources, you can buy articles in newspapers, you can buy large banners, you can buy radio stations and ads on these radio stations, you can actually build ecosystem of the delegates and followers and all that money can buy. So actually in human societies mostly the power is going with money, unfortunately. And similarly, in some of new generation blockchains such as Steemit or EOS, same approach is taken. So the money can either implicitly in case of proof of stake or implicitly in case of delegated proof of stake impact on one's ability to manage the operation of the system. And that's not perfect, because the more money you have, the more control you have, and then the more control lets you earn more money, and then the richer becomes richer, poor become more poor, and then it goes till the revolution when the funds are redistributed and everything starts from anarchy and starts over again. We don't want revolutions and anarchy and suffering, so we suggest the new form of consensus for either society or blockchain systems or any distributed systems based on the blockchain or a hash graph or anything else. We suggest proof of reputation consensus, where amount of one's impact on the network is based on the reputation, and the reputation itself is earned based on the support in community. and support on community based not only on amount of members of this community, but it also depends on reputation of each of the members, and that's quite important to have this hierarchical reputation computation process, because if you don't implement a hierarchical reputation with liquid flow of reputation value across the reputation supporting our audience hierarchy, then you have a case when someone buys a lot of supporters or programs and launches a lot of bots, and these bots are just pumping this fake reputation and make the reputation fake. We call it reputation gaming. And then the consensus is broken, and the cheater may actually perform takeover of the consensus and community. So prevent that, in order to prevent that, we assume that reputation should be computed hierarchically based on liquid flow of reputation power from one member to another. So let's recap what are the ingredients of reputation system. First of all, there are inputs on the left. So the inputs can be either ratings, like likes or votes that we give to particular actions, or to particular posts, or to particular comments, or to particular nominations of particular people, like I vote for someone saying something good, or I vote for someone making to take particular post. Also, there could be stakes. So the stakes are rather long-term kind of ratings, not related to particular events, to particular actions, or particular nominations. So stake means that if I make stake in respect to some person or participant, that means that I just trust this person infinitely for whatever. And also the ratings and stakes may be either virtual, so we just record the fact that the ratings are done or stakes are made, or they may be actually supported by some financial resources, like any ratings or any stake may have any financial value. It depends on the implementation of particular system. Further, we may have no ratings, no stakes, but we may have just payments recorded in the system. And if we have payments in the system, then the fact that someone is paying something to some other participant on an ongoing basis means that there is probably some trust relationship between the two entities. Like if I am paying someone something for something, then there is something that valuable for me coming from this person. So I can actually endorse the person or system or entity with my financial resources. And that's also what can be done and what we actually do, as I will show further. Also, there could be non-financial supports or implicit indication of reputation, like reviews. For example, I can write review for some person, I can comment on the person, or I can mention this person in some publication saying something good or bad about this person. So, and by the way, rating, stakes and reviews can be also negative and positive, and payments can also have positive and negative impact on reputation. For example, if I cancel transaction or if I withdraw my payments during to not completed terms of the contract, then that's actually gets my reputation back from this entity which has the payment returned. That's in respect to inputs. Now, in respect to outputs, what we have as an output is can be called as a rank or reputation or karma or social capital. So you can call it the way you want. In different systems, different sources and different algorithms computing these values may be called differently, but whatever we call them, and which regardless of the specific way we can put them, rank, reputation, karma and social capital indicate the value of the entity being evaluated for the entire society. And now let's go to the middle. Let's see what are the key principles of having this reputation computed. The first principle, which seems to be obligatory, is liquid computation. So that's what I explained before. If we compute reputation of a person A based on the rating, stake, payment, or review made from person B, then we need to account the reputation of person B in turn. So, for example, if two different persons are giving me some review or providing me some ratings, then the person with better reputation has more impact on my reputation after the evaluation of the entire reputations. The other important requirement, which also seems a must, is time scoping. So we need to account the time scope of the rating, stakes, payments, and reviews, like something that was done in order to improve or decrease my reputation during the current week is more important for my current reputation than something that happened in my school time. So I might be a very bad guy in school, but I am better now, and so no matter what bad things you were saying about me when we were in school, now you may trust me much better. And so if you want to evaluate my reputation correctly, we need to consider the actual time frame, and the time frame again may be based on the particular application and particular kind of reputation that we are going to compute. The other the other thing which seems critically important is data openness. The idea that we have about the design of such reputation evaluation, that these reputations should not be centralized. So the reputations shouldn't be issued by one and only one authority center. The reputations should be possibly made by independent reputation agencies. So, and they can be completely independent. On the other hand, these different reputation agencies may be actually verifying the reputations of the same entities in the same communities. So like if I want to be sure that reputation of my partner is reliable, I may be able to validate this reputation in few independent reputation agencies that are responsible for its computation. But then all these reputations agencies should have access to the same data, so they can verify the reputation independently. And finally, even if I am not able to, if I don't agree with, for example, a reputation of my own, if I think that I have inappropriately low reputation, I might want to have a review of the reasons of such bad state of things. So I should be able to have some audit on my reputation history and inspect why it is that low. So that's important to have data opened for audit, made automatically or by human hands in the end case. Another and more questionable issue is whether the reputation system code should be opened. Whether the code of these reputation systems executing reputation calculation algorithms can be opened for community. On one hand, that might be still closed because the code is properly owned by the business running the reputation agency, and the business running reputation agency doesn't want to have this intellectual property taken by others. On the other hand, if we want to have real audit of the reputations, and if we want to find consensus of reputations computed by different agencies, we need to have the code for reputation computing opened for the public. That's actually benefit. And my thought about this is that if we have multiple reputation agencies in communities, then those that have code opened may have actually more value for the audience and for customers. Another interesting requirement on our list is human precedence, and that's pretty important for mixed human-computer environments. The importance of that is given the fact that if some, for example, device in a mixed human-computer environment is given a lot of different ratings by humans and non-humans, then human ratings or stakes or reviews or whatever should have absolute precedence. And that's because our assumption is that the human is actually the goal of the system. So we don't care about the fate of self-driving vehicles or any robots. In the end, we are concerned about the fate of humans, and no one humans can suffer, but we don't care how many robots can suffer. So that's maybe questionable, and there is some argument may be made in respect to giving robots the same rights as humans. But if we want to have humans, to have technologies serving humans, not robots, then the ratings performed by humans should have absolute precedence. But that may raise questions again. Another requirement is non-anonymity. So non-anonymity is actually implied by data openness to some extent, because if we want to be able to audit the reputations, then we need to actually confirm if these ratings, stakes, payments and reviews were done by real humans and not by just some bots created by other humans in order to pump and fake their own reputation. And another important issue is no right to oblivion. So there should be no way to fake the reputation history, removing some data out of it. Unfortunately, these requirements like non-anonymity and no right to oblivion is getting into conflict with some recent legislation regulations in respect to private data. So people have protection for their personal data, they have protection for being for ability to get forgotten online, but then we have the problem with reliability of reputation systems, or we need to make these reputation systems quite expensive so they are able to re-evaluate the reputations in the event if the history of reputations or ratings or reviews or whatever is forgotten by demand of some participant. Now, let's get back, or rather get forward to some practical things. First of all, let's talk about SingularityNET project. In the SingularityNET project, we effectively create not just social network of artificial intelligence systems and services. We actually create marketplace where these artificial intelligence systems, services, robots, and providers of these services, systems, and robots can provide services, can buy services, can cooperate in respect to providing particular services cooperatively, and all that should be open sourced and auditable by other agents and humans because of the reasons that we have just discussed. And one piece of the conceptual design of SingularityNET platform is what we call reputation system, and reputation system can be considered in different parts. The bottom part is technical low-level layer, which provides a source for different input data for reputations like transactions, payments, ratings, stakes, whatever, and also it can provide the storage for reputation data. On the upper side of the image, there is kind of business logic layer, which also has two parts. On the left, there is agent part or agent API, which provides basic functions to update the current reputation of anyone by anyone, and to provide current reputation evaluation for anyone in respect to any other agents. So the decision based on the reputation of any combination of agents may be done by any other agent. And on the right, there is a API or a system which we call reputation agency, and that's the system which actually takes the input data from the storage below, and it computes the reputation states of each member of community. And in our current thinking, there could be multiple reputation agencies operating in the same environment, and moreover, these reputation agencies potentially may have different implementations and potentially even different algorithms to compute this reputation. On the other hand, it's interesting to have it's interesting option to have multiple reputation agency finding consensus in respect to what we call reputation state or reputation image of the system, like reputation values of any member of the system at given day may be negotiated by multiple reputation agencies, and then once the consensus is found across them, then it goes further for the next cycle. Another related project is the project that I'm working on since 2014. It's called the Aigents project. The goal of the Aigents project is provide personal agents of artificial intelligence for every human on Earth. And one of the functions of it which we are developing now is exactly the reputation agency. So our personal agent may serve as a reputation agency, given it has input to reputation data taken from Ethereum network blockchain, Steemit and Golos social networks on blockchain, and some of the social networks like Google+, Vkontakte, and Facebook. For the latter social network, the amount of information available for reputation computing is limited by privacy restrictions imposed by these social networks, of course. And by the way, for Facebook, recently it's almost useless for reputation computation because they actually have closed access to anything, to almost anything reasonable. And the mission of the Aigents project is to provide reputation agency service for distributed applications and markets, and we work with a bunch of partners in order to reach such goal. And here are just a few examples. That's example created just with synthetic data, and on this example you can see something like you have multiple media sources providing news content, and you have a bunch of people, and you have ratings or rates conducted by some people to other people, and also people can provide rates to the news sources, and also we may consider information that people are funding these news sources either by investing into them or just paying them for service, and then we can compute reputation of people, of media sources, or each of them individually. Another kind of reputational analysis that we can do is evaluation of social types of communities, like we can consider case when there is one follower with many opinion leaders, or there is one opinion leader with many followers, or there is a bunch of peers having symmetric or peer-to-peer relationship without of any expressed leader or follower, and finally there is a social type connector or hub which has two influencers or opinion leaders at the top and some supporters or followers at the bottom. And then the case 3 is again, it's computed on the real data from Steemit blockchain and social network, where we can search for opinion leaders starting from the top image. We select one person, then we go to the leader of the topmost leader of this person, and then on each of the next person following green arrow we select the very topmost opinion leader on the top of the chart, and going further and further and further, and in the very end, in the bottom left corner, we reached the account which has huge number of supporters, but this guy is not actually following anyone itself or herself, so that's true opinion leader in this community. And finally, here is example that we are doing on Ethereum. So here is reputation graph on Ethereum. So the position of the account on the vertical axis corresponds to amount of reputation computed from financial transactions, and the width of arrows is corresponding to amount of funds being transferred, and direction of the arrow also corresponds to direction of fund transfer. And so we can evaluate who is the accumulating the funds and who is the provider of the funds. And that was all, and I welcome you to provide your feedback. We are quite interested in your possible cases where reputation systems and liquid democracy can be useful in your community, in your work, in your business. And we have many companies that we are working in this direction now. So if you want to help us to advance this topic, then give us what you need and we will work on this together. Thank you. Goodbye.